In the Middle Ages, alchemists chased a dream that seemed impossible, turning ordinary lead into shimmering gold. Today, it might sound a bit naive, but they dedicated their entire lives to this idea. History books often describe them as strange, obsessive old men, but there's something those books didn't know. Their dream wasn't entirely impossible. Yes, today we know that gold can actually be created, but the secret doesn't lie in dark, smoky laboratories. It's hidden much farther away. So how did gold's story on Earth begin? Did it slowly form between rocks over time like oil? The truth is far more complex. Gold doesn't even belong to Earth. It was born in the heart of the most violent events in the universe and arrived on our planet from the depths of space billions of years ago. Think about it. The jewelry we wear is actually a relic of cosmic cataclysms. But how does something that begins its journey in a dying star end up as a tiny ring on our finger? Come with me. Let's explore the incredible journey of gold from space to Earth. To understand gold, we must first understand stars. Everything starts with hydrogen, the simplest, lightest, and most abundant element in the universe. Young stars are almost entirely made of hydrogen, which serves as the first fuel for nuclear fusion. Under immense pressure and temperatures of millions of degrees, hydrogen atoms overcome their natural repulsion and fuse into helium. This process releases massive amounts of energy, allowing stars to shine. In the core of our sun, billions of hydrogen atoms are fused into helium every second, and the energy released in just 1 second surpasses everything humanity has ever produced. Stars are like cosmic power plants, but nothing lasts forever. As stars age, their hydrogen fuel runs out. Then helium becomes the new fuel, fusing into carbon, oxygen, and increasingly heavier elements. Each new element becomes the fuel for the next, like a cosmic production line. But here's the twist. Each new fuel burns faster than the last. The star's life speeds up, becoming a countdown toward its end. And when the star starts producing iron, the process suddenly stops. Why? Because unlike previous elements, fusing iron doesn't release energy, it consumes it. At that point, the star can no longer hold itself together. Its core collapses under its own weight, then violently rebounds, triggering one of the most spectacular events in the universe, a supernova, the cosmic factory of heavy elements. A supernova is one of the most powerful events in the cosmos. It can shine brighter than all the other stars in its galaxy combined, and sometimes can even be seen with the naked eye for days or weeks. At the core of the explosion, something extraordinary happens. The pressure is so intense that protons and electrons are forced to merge, creating neutrons. This is when the cosmic factory of heavy elements switches on. Gold, platinum, uranium, the rare and valuable elements we find on Earth, are actually the remains of dying stars. Neutrons have a special feature. They have no electric charge. This allows heavy elements like iron to easily absorb them. As more neutrons are captured, heavier elements than iron are created, like silver, gold, platinum, lead, and uranium. And here's the most mind-blowing part. While it takes millions of years to turn hydrogen into helium, these heavy elements form in just a few seconds during a supernova. The universe's most precious materials created in the blink of an eye. How did gold get to Earth? The shock waves from the explosion hurl these freshly made elements into space. Gas and dust clouds spread across the galaxy, eventually forming new stars and planets. Gold formed in supernovae and neutron star collisions, then hitched a ride to Earth on meteorites billions of years ago. But the journey didn't end there. As Earth's interior boiled and churned, geological activity slowly pushed this rare metal toward the surface. Over millions of years, it accumulated in veins beneath the crust, and eventually we dug it up, mined it, shaped it, and gave it meaning. But here's something to think about. Gold is about 20 times heavier than water. And yet, if we gathered all the gold humans have ever mined, it would only fill 3 to 5 Olympic swimming pools. Thousands of years, countless workers, massive machines. And the result? Just a few pools of gold. That's why gold is so incredibly valuable. Why is gold special? Its value isn't just about rarity. Gold has some unique properties. It doesn't rust, tarnish, or decay. Gold objects buried for thousands of years, like those in pharaohs' tombs, still shine as if brand new. It's incredibly malleable. Just 1 gram can be beaten into a nearly transparent sheet covering 1 square meter. That's why gold is used in art, jewelry, and even in electronics, at the heart of our phones and computers. Can we make gold? Actually, yes, in theory. With particle accelerators, we can mimic the nuclear reactions of stars. But here's the funny and somewhat tragic part. These machines can only produce a few atoms of gold at a time. To get just 1 gram, you'd need to wait longer than the age of the universe and spend more money than even Elon Musk would dare to spend. So, yes, it's technically possible, but completely impractical. What if we run out of gold? If Earth's gold reserves ever dry up, we'll have to look elsewhere. One option? The oceans. Scientists estimate there are around 20 million tons of gold dissolved in seawater. Sounds amazing, right? But here's the catch. That gold is so diluted that even a whole Olympic pool of seawater would contain only a few grams of gold. So scattered that extracting even a single particle is practically impossible. The cost of extracting it? Thousands of times more than the gold itself is worth. So what's next? Space mining? Maybe one day technology will allow us to extract gold from the oceans, or maybe we'll look even farther, to the asteroid belt. Astronomers believe some asteroids may hold more gold than all the reserves on Earth. Imagine that! A future where robotic arms clamp onto asteroids, laser drills cut into rock, and mining ships float through space, searching for cosmic treasure. Gold may no longer be rare. Gold and jewelry may just become nostalgic keepsakes. And the next gold rush won't be on Earth. It'll be among the stars. If you've made it this far, thank you for watching. If this video taught you something new, your support means the world to me. Don't forget to like, subscribe, and share your thoughts in the comments. As long as you're here, I'll keep creating more. See you on the next journey.